Alright, so this is day 3 of our quadratics section. It's a little bit of a review of some of the basics of graphing that you might need to know, or that you will need to know, I guess. And then a couple of things that are a little bit new, like increase, decrease, and then on the back side there's going to be some stuff about average rate of change. So I'm going to do half of these problems, and the other half will be ones for you to practice. If you have questions about things, let me know, and I can always shoot you an email to let you know if you did it correctly or not. So first one I'm going to do is this graphing one. Now 4 of these points are already given to us, so we're going to start by actually graphing those. So -1, -9 would be right there. 0, -8 is right there. -4, 0, and 2, 0. And you can see kind of the U shape of the parabola that we're used to. So we'll go ahead and draw that through. Just make sure to remember that it's a U shape. It shouldn't be straight lines. It should be a nice curve shape, and then arrows at the end. Now, a vertex is the bottom or the top of the U shape, depending on if it's a maximum or a minimum. Now this one, you can see the bottom point is right there. That's the vertex of our parabola, and it's at -1, -9, so I'm going to write that in. And because it's the lowest point, that makes it the minimum. Maximum would be the highest point if it looked something like that instead. X-intercepts. Intercept means to cross something. Like if you think of an interception in football, it's when two things cross paths, or a football crosses another player's path. So here, x-intercept is where the graph crosses the x-axis. And then obviously y-intercept would be where it crosses the y-axis. So on my graph, here's my x-axis, and my parabola hits it at 2 spots. One of them's right here, one of them's right here. Those are my 2 x-intercepts. And I guess I can put them in green to actually match my colors. There we go. And so I've got -4, 0, and +2, 0. And then my y-intercept is where it crosses the y-axis. So I look at this one. There's only one spot where that happens, which is right there, and that is -8. So it's 0, -8. Now, axis of symmetry is a little bit of a new phrase for us, but symmetry is not. Symmetry simply means that it's the same on both sides. If you think about your face, if you split it down the middle, should be kind of symmetric. It's not going to be exact because we're human. And it's going to be symmetric on both sides. The axis of symmetry always goes through the vertex because the vertex is in the middle. So if I draw a dashed line through here, that is my axis of symmetry. And you can see the points kind of reflect on either side. I've got this one that's 3 spaces away, and then its reflected one over here is 3 spaces away. Now, it cuts through the number -1, so I have to use that number. But I need to finish it a little bit. It's cutting through the x-axis. See how it cuts through right here, the x-axis? So it's not just -1, it's x equals -1. That's how we name a line. So make sure you're kind of aware of that. We've then got domain and range. Now this is where it gets a little bit trickier. We haven't talked about those in a while, so it might be new for you. Domain you can think of as the left and right side of the graph, and we use these bars to kind of help us remember. And I'm actually going to draw the bars into my picture, or actually I might cheat and just have the computer do it for me. And yeah. Okay. So let's see if it'll let me do it. There we go. So, poorly drawn, but that's my left and right side of the graph. Now, normally I would look at where it cuts through on the x-axis. However, there's something really important right here that I need to pay attention to, which is those arrows. Now what those arrows mean is that it's not just going to stop at -5. This graph really continues up and to the left forever and ever. So I'm going to get an x value at -6, -10, -100, and really forever I'm going to get negative values. What we do for that is we call it negative infinity. Now I need to go back to my regular. There we go. Negative infinity. On the right side, kind of the same idea. This is going to keep increasing and going off to the right, which means I'm going to get something at 5, at 10, at 20, at 1,000, at infinity, really. And all those numbers are positive over there, so that would be positive infinity. So here's our domain. It's telling me what are all the possible x values to the left and to the right that this graph could possibly have. And actually, for every parabola we will do, it's always going to be the domain, because whether it's this way or this way, doesn't matter. The left side and the right side always have arrows, so it's going to continually go both directions. So that's always going to be your domain, so kind of keep that in mind as you work through. Might even want to make a note for yourself that this is always that. Now, range is a little bit more, not complicated, I guess, but you have to think about it a little bit more because it's not going to be the same all the time. Let's change a different color. Let's go orange. So, range, if domain is left and right, range is bottom to top. In other words, it's the y values that my graph can encompass. So at the bottom of my graph, this is the lowest point. I'm not getting anything at 10 or 12 or 15, so I'm going to draw a line cutting through here. And then the top part would be where those arrows are. Now, the top obviously is not going to have a stopping point. There's arrows there, so we'll get to that part. But this bottom section is definitely going to have a stopping point because there's nothing past here. So because there's a definite stopping point, I use a bracket. Parentheses are for infinity because infinity is not really a real number. It's more a concept, so it's not an actual point I can put on a number line. So this one, if I look at this line, it cuts through at -9. That's the lowest y value I can get. So my range starts at -9. And then if I continue up, the y values keep going and going and going. And because these arrows are there, it really means I'm going to have y values available forever. So this is positive infinity. So that would be my range for that one. So a little bit more to think through with domain and range. Kind of tricky. The last one I'm going to go through on this graph is the increasing and decreasing part. Now this one is where it gets really tricky, and a lot of people have struggles with this, so feel free to rewind and hear this again if you need to. Now think about this in a real world sort of sense. If this was, say, a diver's path, you know, if you look at a diver, if there's someone diving underwater, you see them kind of dive off from the jump board and then they go underwater, and then at a certain point you see them start to go back up to surface, right? Okay, a little diver person there. Okay, so think about this graph as a diver. They're jumping from really high, going underwater, and then at a certain point they come back up. Okay, now because of that, we have to think of increasing and decreasing in terms of that. So in my picture, and notice, and remember, I always go from left to right with a graph because that's how we read graphs, kind of like how you read a book. So if he starts here and he goes like this whole half of the graph, in other words, this side right here, he's diving underwater. Is that an increase or a decrease? Well, it's a decrease. He's going underwater. So this section is decreasing. After this point right here, which is really our vertex, he starts to go back up to the surface again, which is an increase in the graph. So even though in my picture I've got arrows going up both ways, if I really truly read it the way it's supposed to be, and I go this way, from here it's going down, and then it starts increasing afterwards. So kind of keep that in mind as we are writing our increase, decrease stuff. So let's move that guy off to the side. Alright, so increasing. Let's start with the decreasing one. So over here it's decreasing from here to here basically. So I need to name that interval. This is what an interval is. It's something comma something showing how far the section of the graph is going. So if I start here, the graph starts increasing right here. Now I can't say that it's -5 because that's not really where the graph started. This arrow really truly means it started all the way back up here. So it started decreasing at negative infinity. And it decreased, 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 all the way to right here. And I'm not looking at the orange, I'm looking at the x values, sorry. So I'm going to say that it stopped decreasing at -1. And again, I got to put a bracket there. Okay. If it stops decreasing at -1 here, that means it starts increasing at -1 here. And now it's going up, 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 all the way this way to positive infinity. And if you do it correctly, you should kind of encapsulate all numbers. Negative infinity, it should keep all the numbers. So negative infinity to -1, starts at -1, goes to positive. So that should take all the numbers. Alright, so you are going to try this one then. Do all the features that are there. If you want me to check it over when you're in class, feel free to. I'm going to flip over to the back side and give you this example and then also this example. Alright, so first of all, something you need to know about this is that average rate of change is really just a fancy word for slope. And if you remember from when you learned slope, slope is rise over run. Now when I have a graph, that's awesome to have. If I don't have a graph, I can always use this formula, which we'll get to towards the bottom, but since I have a lovely graph here, I don't have to worry about that. Now, this right here is what tends to throw people off, is figuring out where the heck these numbers fall on the graph. Well, x equals -3 is the first one, and x equals 0 is the second one. So find -3 on the x-axis. Okay, that would be this whole line right here. -3 goes all the way here and up. So where does the red parabola hit the graph at -3? Well, it hits it right there. That's the point that they're referring to, is really -3, 0. Same thing with 0. If I go to 0 on the x-axis and I look up and down the whole thing, the parabola hits 0 down here. I can't use this point. There's no part of the parabola there. I want where's the parabola hitting the x value of 0. So it's really 0, comma, -6. Now you can use the slope formula. I think it's a little bit easier when there's a graph to actually use the graph itself. So I'm going to show you that. Rise is the top number, and rise is either up or down. You always have to do that first. Remember, we read a graph like a book, so we go this way, left to right. So I'm going to start here, and to get to the second point, I have to go down. And I have to go down 1, 2, 3, 4, 5, 6. So down is negative. And then run means I always go to the right, because I always read it left to right. And so I go right, 1, 2, 3. And then don't forget to simplify that. So that's really -3 over 1. And I did that by dividing by 3 in the top and bottom, just so you know. Oops. Apparently, Mrs. Crawford can't do math in her head because it should be -2. Alright. You need to try this one next. And then the last example I'm going to do is this one. Now, obviously with this, I can't find the slope with the picture, so I'm going to have to use my formula. So I'm going to write that off to the side again. And this time, I'm going to have to actually plug this in. So I'm going to tell you right now, it's a lot more work with this one. So this time, in order to figure out what my point is, I know it's 1 comma something and 5 comma something. I'm going to have to plug these in. So if I plug 1 into the x spot, it looks something like this. 1 squared is 1, minus 1 is -4, plus 10 is 6. Same thing if I plug in 5. 5 squared is 25, minus 25 plus 10. This is 0, and that makes 10. So those are my 2 points I'm going to use. Plug them in here. And I apologize for going so fast. This just appeared because I wrote it out already. So I have 10 minus 6 on the top for the y's, 5 minus 1 on the bottom for the x's. 4 divided by 4 actually simplifies down to